Hello everyone and welcome to the 5th webinar of BETaaS, which will show you about running applications on BETaaS enabled proprietary devices. This webinar has the following overview. First, we will have an overview of the BETaaS platform. Then we will briefly describe the BETaaS connectivity. We shall then see the proprietary system of Converge called Ecosystem. Then we will go through the steps required for making Ecosystem a BETaaS gateway. And finally, how we can combine two ecosystems in producing two BETaaS gateways for creating a BETaaS instance. So, generally speaking, this is the BETaaS platform architecture. With red, we have the physical layer with the actual devices and their API protocols for communication, which connect to the adaptation layer or the adaptation layers of BETaaS that give to the heart of BETaaS, the TaaS, what it needs in order to provide an abstract view of the things as a service. So BETaaS at the end produces several service modules upon which the applications can take any data they need and provide any data they like to the actual things. Another thing to notice here is that the adaptation layers stay on top of any specific M2M implementation, meaning that we can have different communication protocols. So here we have another view of the architecture, starting from the physical where we have a different set of devices that cannot communicate between them, to the adaptation where we create a gateway for each of these set of things, and to the TaaS part of the architecture where we join these gateways in order to have a single instance from which the services can take the information they need. The connectivity of BETaaS on the physical layer can be seen as the way to connect different sets of services, of devices that are totally unrelated between them. Now, for the ecosystem is a proprietary Java-based system that provides building management service capabilities to the user. It orchestrates analog and digital sensors and actuators from various APIs and protocols. It covers all mechanical and electrical requirements of a building, such as temperature, lights, presence, door traps, etc. It is very friendly to use and has a simple graphic user interface. The installation is easy for both existing and, of course, new building infrastructures. Its ultimate target is to combine and integrate the sensor data in order to decide, based of course on user input, for actuator actions. It combines both digital and analog inputs, of course, and digital outputs. The range of the protocols is wide enough to cover the Sienna Longworks, which uses the power lines to transfer signals, as well from TCP-based PLC boards. Each protocol is an independent service which can be started or stopped, and they all implement the same interfaces, which means that we can have a top layer of user interface for the same for every kind of protocol. It also has communication modules such as SMS and email. In order to enable, to BETaaS enable the ecosystem, we need, as for any other external system, to have a well-defined and structured API, which ecosystem does. And from the side of BETaaS platform, we have to comply with the iAdapter plugin interface. So through the well-defined structure and well-structured API of ecosystem, we use several REST services which ecosystem exposes as AJAX calls in order to firstly request permission from the ecosystem through a set of credentials and take a session ID out of it, which will then be used as a parameter for getting the available device and IDs, and send commands to devices or read data from devices. All this, as I explained, is happening through a very distinctive services which are exposed through AJAX calls. Now, from the BETaaS side of view, we will show how to implement the iAdapter plugin in just a single Java class, the iAdapter plugin impl, let's say, for example, that will do all the job required for connecting with the ecosystem. First, the start method will get the session ID from the ecosystem, as we saw in the previous slide. Then the discover will be used in order to fetch the things, the actual devices from ecosystem, which will be transformed to things in the BETaaS side. The register for any service that is interested, and unregister are typical BETaaS implementation, and they are standard. The set data will send command to the devices, the actuators, and the get data will receive data from devices, the sensors of ecosystem. So through these very simple steps, we have a complete BETaaS service. An example of it is the following, where we set to a switch called the garden valve to either switch on or off. So how can we combine, and what is the main target behind combining two ecosystems? This is because we can have two versions of ecosystem that are totally unrelated, let's say a domotic system and a security system. These have a set of services which are meaningful only to them alone. For example, the temperature for the one system cannot be used by the other. On the other hand, with the help of BETaaS, we can combine these services by firstly creating two gateways. Gateway 1 from the security and gateway 2 from the domotics. These two BETaaS gateways will give us a BETaaS instance where all the services will now be available for any application that wishes to access them. So before we had two sets of totally unrelated devices and their respective services, but now we have a combination of the two systems in one BETaaS instance, where the application can now connect and read and send data. So that was all, and thank you very much.